Hi friends, as always I'm super excited to see you here. If you're meeting for the first time, I'm Shankar Pandey and this is the Dr. USP channel. I host videos on media, communication, statistics and research on this channel. To stay updated with the latest on this channel, I urge you to consider subscribing to the channel. The chi-square test is a very important statistical test to test for association between two nominal variables. So let's find out how to do the chi-square test in SPSS. There are two different ways in which the chi-square test can be done on the SPSS interface. One is through the descriptives tab, the other is through the non-parametric test tab. Today we'll be using SPSS to do the chi-square test. We use the same data set we've used for our earlier tests. So the age group has three values: middle, young and senior. In which area you reside is either rural or urban. So as we can understand, these are two nominal variables. We can toggle the values. So 1 for young, 2 for middle, 3 for senior, and 1 for urban, 2 for rural. If you want to see the values, we have to go to the variable view, age group, we can see the values, 1 for young, 2 for middle, 3 for senior. And similarly, in which area you reside, 1 is for urban, 2 is for rural. In the data view, we can toggle between the value and the labels just by clicking onto the value labels here. If I click onto this, it will be back to middle, young, senior, etc. So the chi-square test is easily done using the analyze, descriptive statistics, and from there crosstabs. So generally we have to put the two variables among which we want to find out whether there is an association or not in the rows or columns. So we can put either of them in rows or columns. But by convention we put the independent variables in the rows and the dependent variables on the columns. So for example, in which area you reside, it can be in the rows. Age group, it can be in the columns. We have to provide certain values here. So we click on to chi-square because that's what we want to find out. We generally go for phi and Cramer's V. And that's all for this test. In cells, I can just click on to expected values also. By default, only the observed values is clicked. I can check in the expected value also. The others I can just leave it like that. At times we might require to have rows and column with the percentages also, but we are not doing it here. Okay. So we come to the SPSS output. So it's telling me that there are 178 observations, and this is what is the cross tab between where do you reside, in which area do you reside, and the age group. So if we see here carefully, in the urban, the count for young teachers is 50. The count for the middle-aged teachers is 36, and the count for senior teachers is 40. In the urban area, the expected count for the young teachers is 52.4 and it is 50. The expected count for middle-aged teachers is 41.1 and it is 36. The observed count, and similarly for the senior teacher. In rural, expected count for young is 21.6 and we get 24 here. Similarly, in rural, the expected count for middle-aged teachers is 16.9 and we are getting 22 here. But for senior teachers, the expected count is 13.4 and we get only 6 here. So we can see here from this test of association that there are fewer senior teachers from rural areas. And let's find out whether it is statistically significant or not. So the value of the Pearson chi-square is 8.319, but a very important thing to note here is this value here. It says that 0 cells have expected count less than 5, and this is a requirement for the chi-square test, that not more than 20% of the cells can have an expected count less than 5. The chi-square conditions are satisfied here. And the Pearson chi-square value is 8.319. And this asymptomatic significance, which is the p-value, we are getting it as 0.016. So we can see here this is significant at the 0.05 level. This proves the hypothesis that there is an association between the age group of the teachers and whether they belong to rural or urban areas. In fact, in rural areas, the teachers are more likely to be younger. So in rural areas, there is a smaller number of senior teachers. This is very similar to the effect, either the phi or the Cramer's V. For this case, we can see that they are both similar. So 0.216 means the effect size is moderate. This is one way of doing the chi-square test. The other way is using this non-parametric option. So we go to Analyze, Non-parametric tests, Legacy dialog, chi-square. So we can take this age group here, and there are some important inputs here. We are trying to find out whether the count of teachers in the age group as expected or it is different from what is expected. So for example, we can use the point of all categories are equal. That means expect every group to have similar number of teachers. So if we go ahead, and we'll see that we expect every group to have 59.3, because 178 divided by 3 would be 59.3. And we can see here that in the younger group there are 14.7 more teachers, and in the senior group there are 13.3 or around 13 less teachers. So this is significant. Or if we require each cell to have similar number of values, we can see that requirement is being violated. That here we can see that they are different across different groups. On the other hand, if we specify certain values, for example, if I go to the same test, Analyze, Non-parametric test, Legacy dialog, chi-square, and we give them certain values. For example, I expect younger teachers to be 40% of the total, or any value. So if we are having a number of observations, we have a hypothesized percentage of what the observations could be, or we can use this method. So we are suggesting that the younger group is 40%, the middle-aged group is 30, and the senior group is 30. So here we can see that younger teachers, they're expected to be around 72 and the observed is 74. So almost that is 3 more than what is expected. The middle-aged teachers and the observed is 58. So that is 5 more than expected. Among senior group also there is 8 less than expected. But is it statistically significant? Are these differences statistically significant? And if we go to the test statistic here, we can see that they are not significant because the p-value is more than 0.05. Although we can see certain differences here, but they are not statistically significant. So this is another way of doing the chi-square test, of trying to find out whether the observed frequencies are different from the expected frequencies in a statistically significant manner. Thanks for staying along, friends. As always, it was a delight having you here. I'll be back with another video very soon. Till then, have a great time.